Hey everybody, welcome to cyber school, I guess. We thought we'd be doing this, but here we are. Today we are going to start our first lesson on quadratic equations. Now, we've seen the word quadratic before. In fact, before we left, we were learning about how to factor quadratic equations. I really hope that you pick that skill up, because if you don't know how to factor, you're not going to be able to do anything that I talk about today. We'll get there when we get there, though. For now, let's just kind of talk generally about quadratic equations. And in general, a quadratic equation is any equation where the highest exponent paired to an x is 2, right? The highest exponent paired to an x is 2. I could have just said a quadratic equation is anything that has, an x squared, but you have to be a little more specific than that. So let's just look at some of these examples here, right? So we're going to determine whether each of these is quadratic or not. The first one you see is 3x minus 1 equals 4. Do I see an x squared anywhere? I don't, right? That means this one is not a quadratic, right? There's no x squared, it's not quadratic. Now the next one is x squared minus 3x plus 4 equals 10. I do see an x squared, but there's also a minus 3x hanging out there, right? That minus 3x does not mess us up at all, because my highest exponent I see is an x squared. That means this one in the middle is a quadratic equation. So it is a quadratic. And this last one that I see, x cubed plus 2x squared equals 10. I see an x squared, so I might think that this is a quadratic equation. But the highest exponent that I see here is not x squared, it's actually x cubed. Since the highest exponent is x cubed, you can't really call this a quadratic equation. So this one is not a quadratic. So we are only going to be focusing on equations that actually are quadratic. I just want us to have a general understanding of what that actually means, right? What is a quadratic equation? It's something with an x squared, an equation with an x squared. But that x squared has to be the highest exponent, or else it's not considered a quadratic equation. Now, you should all know how to solve this one, right? 3x minus 1 equals 4. This is a linear equation. This is a general basic two-step equation. But you're not going to be able to use those same techniques to solve quadratic equations. I mean, for one, they look weird, right? X squared minus 3x plus 4. In order to solve something like this, we're actually going to need special methods. There's quite a few of them. For us, we are only going to be focusing on factoring, graphing, and then the quadratic formula. 3 different methods for solving an equation. Now, when we talk about solving an equation, right, usually when you solve an equation, you get an answer like x equals 7 or whatever, right? For a quadratic equation, there's actually 3 different possibilities. Either the quadratic equation has no solutions, right? Remember, regular equations can have no solution as well. So it's possible there's no solution. It's possible that there's one solution. And it's also possible to have 2 solutions. In fact, most of the equations that we see are going to have 2 solutions. So right now, we're just kind of going over the general overview of what a quadratic equation is, what they look like, how you could solve them, or at least the names of the methods that you could use to solve them, and how many answers we could possibly be getting, right? And if there's two answers, you always give me both of them, right? You're not picking one or the other. You always give me both answers. So let's talk a little bit about how to actually solve these quadratic equations. And today we are only going to focus on how to solve a quadratic equation by factoring, right? Everybody's favorite thing to do in the world, factoring. Now, before we even get into that, though, let's talk a little bit about something called the zero product property, right? So the zero product property is very basic. It simply says, if two or more things multiply to zero, one of them must be zero. Think about it. The only way you could multiply two numbers and the result is a zero, one of those numbers had to be zero, right? You know, you multiply regular numbers together, right? 2 times 3, that equals 6. 7 times 5, that equals 35. The only way to make this equal 0 is if you did something like 7 times 0, right? The only way to multiply numbers to equal 0 is if one of those things equals 0. So if I were to have something like up here, right? I have x times y equals 0. Well, if that's true, right? If it's true that x times y equals 0, that would mean either the x equals 0 or the y equals 0. One of those two has to be true. Otherwise, there's no way that these two would, multiply to 0, right? Again, it's one or the other, but you have to give me both of them, right? You have to say x equals 0 or y equals 0. That is the solution, right? So again, everything we're going to be doing for the next week or so relates to this zero product property. That when you multiply two things and they equal 0, one of them has to be 0. Now, how do you actually use this to solve a quadratic equation, right? It's not really that hard unless you find factoring hard, right? If you find factoring difficult, then this is going to be incredibly difficult for you. So how do you use the zero product property to actually solve a quadratic equation? Well, step 1, you have to make the equation equal 0, right? If everything I just said depends on it equaling 0, then that has to be your first goal, right? Make it equal 0. So as I talk through these steps, let's work out an example. So over here, we're going to solve for x in this equation. X squared plus 5x plus 6 equals 2. Now, the first step says to make the equation equal to 0. So right now, the equation does not equal 0, it equals 2, right? So how do we fix that? Well, if I wanted to solve this equation to make it equal 0, that means this 2 that's on the right-hand side, I don't want it on the right-hand side. I'd like to get it over to the left-hand side, right? And couldn't I do that by just doing minus 2, right? Because 2 minus 2 would equal 0. But remember, you're solving an equation. If you do something to the right-hand side, you have to keep it balanced. You have to also do it to the left-hand side. So if I'm subtracting a 2 on the right of the equal sign, I also have to subtract a 2 on the left of the equal sign. Notice where I put it. I put it under the plus 6. Why did I do that? Remember like terms, right? This 2 does not have an x, so I couldn't combine it with this 5 that has an x. It does not have an x squared, so I could not combine it with the x squared. I can only combine a 2 with another number, right? Another constant term. So, I have 6 minus 2, which would give me 4. And the rest of the equation I can just bring down, right? X squared plus 5x plus 4 equals 0. So now my first step is done. I made the equation equal 0. Now I will tell you that most of the time, not all the time, but most of the time, the first step is actually done for you. A lot of the problems that you'll see will already equal 0, which means you just don't have to do the first step, right? You can just move on to step 2 and step 3. So I've done that, right? I've made the equation equal 0. Now I have to factor the quadratic expression. This is what we had spent 2 weeks doing before we left for this break. X squared plus 5x plus 4. That's a quadratic expression, right? And factoring this, remember we learned quite a few different ways to factor, right? We talked about using a GCF, we talked about the difference of squares, and we talked about factoring trinomials. This so happens to be a trinomial, right? So, how do I factor something like this? If you recall, x squared plus 5x plus 4. It's a trinomial, and I can break it down as 2 factors. Right? This is kind of doing the reverse of the FOIL method. So, first of all, do you notice that the way I just set it up here looks very much like this? Right? X times y equals 0. Something times something else equals 0. Now, in order to do this, right, I know that my 2 factors, right, the first term has to multiply to x squared. Now, the cool thing about that is there's only one way to do that, and that would be x times x. Then, we need to find 2 numbers, right? Because we need to figure out what the rest of the expressions are. I need to find 2 numbers that multiply to 4 and add to 5, right? So, let's think about numbers that would multiply to 4 and add to 5. Remember, you multiply to the end term and add to the middle term. And the only 2 numbers I can think of that do that would be 4 times 1, because 4 times 1 equals 4, and 4 plus 1 equals 5. So the numbers that I was looking for, the numbers that belong in the parentheses, are 4 and 1, right? Positive 4, positive 1. So I get x plus 4 and x plus 1. So what I just did is I factored this quadratic expression. X squared plus 5x plus 4, you can break it down as x plus 4 times x plus 1. So now look at what I have. X plus 4 times x plus 1 equals 0. Something times something else equals 0. doesn't that mean that either x plus 4 equals 0 or x plus 1 equals 0? Here's the way it works, right? Look at step 3. It says set each factor equal to 0 and solve. So I have two factors, right? I have x plus 4 and I have x plus 1. Here's what I like to do. I draw a line right in between the two factors to give myself some space to work. And the left factor is x plus 4. So what this means is x plus 4 must equal 0. Or x plus 1 must equal 0. One of those two things has to be true in order for this to actually work out. Well, look at the equations that I just made for myself. X plus 4 equals 0, x plus 1 equals 0. Those are one-step equations. So doing this, right, takes a quadratic equation that's just normally hard to solve, and it turns it into two very simpler equations. Now we should all know how to solve x plus 4 equals 0, right? You just subtract 4. So one of my answers, 0 minus 4, you get negative 4. Same thing over here. If I subtract 1, 0 minus 1 is negative 1. And those are my answers, right? The solution to this we're going to say x equals negative 4 or x equals negative 1. So x equals negative 4 or x equals negative 1. I made it first equal to 0. I then factored the expression, and I then set each factor equal to 0 and solved very basic equations. That's what you're going to be doing for your assignments on your quiz, right? What I want to do is just go over a couple other examples, just so that way you can see how this works with other methods of factoring as well. Let's see how fast I can erase. Not too bad. Okay. So let's solve for x. So 3x squared minus 2x equals 4. No. Equals 0. Sorry. So 3x squared minus 2x equals 0. Remember how I said that some of the equations will already have step 1 done for you? Here's one of those examples, right? So 3x squared minus 2x equals 0. We already have it equal to 0. We now have to move on to the next step, which would be to factor it, right? Now, 3x squared minus 2x. This is my quadratic expression, right? You're just looking at this left-hand side. That's not a trinomial. So we can't use the method that I was just talking about. It's also not the difference of squares, right? The difference of squares would require us to have perfect square numbers, like 16 or 25 or 36 or 49. These are not perfect square numbers. But if you remember, when you talk about factoring, you always want to think about a GCF, a greatest common factor. So with 3x squared minus 2x, they only share one factor in common, and that's x. They both have an x attached to them, so I can factor out a GCF of x. What does that look like, right? You take the x out, and then you're left with parentheses. How do I fill in those parentheses? Well, once you figure out the GCF, don't you just divide everything by that GCF? 3x squared divided by x. I'm just taking out one x. So that's going to give me 3x. And if I take an x away from 2x, I'll just get 2. So it's 3x minus 2. So far, all I did was factor by taking out a GCF. Now, if you look at this, what are my two factors? I have x, that's one of them, times 3x minus 2. There's the second one. So x, 3x minus 2. Those are my two factors. So what I'm going to do is I'm going to draw my dividing line right here. Because that's where my two factors are split, right? So I'm going to draw this like extra thick here. Now, it might seem a little too easy, and that's because it is. Over on the left-hand side, the only factor I have is an x. So one thing I can say for sure, x has to equal 0. It must equal 0. Or the other one, 3x minus 2 equals 0. So I have two different factors, x and 3x minus 2, and one of them must equal 0. Now I just solve both of these equations. Well, hey, guess what? This one already solved for. It's the equation on the right that's more of like a two-step equation. It's still easy enough to solve. So what do? Add a 2 and get 3x equals 2, and then divide by 3 to get x equals 2/3. And that's my solution, right? If I was going to write it out, your solution, x equals 0 or x equals 2/3. Pretty easy. I just factored out a GCF, set them both equal to 0, and solved. Let's do another. And let's do a difference of squares problem this time. But first, let's do it like this. X squared equals 9. That one is not set up for us yet, right? We first are going to have to make this equation equal 0. Right now it equals 9. I want it to equal 0. Well, it's pretty easy enough to do that, right? You just have to subtract a 9 from both sides. Keep in mind, however, you're not going to be able to do x squared minus 9, right? You can't combine those. So I'm just going to write x squared minus 9, and then 9 minus 9 equals 0, right? So I subtracted a 9 from both sides, and then I end up with x squared minus 9 equal to 0. See that x squared minus 9? I hope you recognize that that is a difference of squares, right? x squared is a perfect square, 9 is a perfect square. Difference of squares. Oh, difference? You mean like subtraction? Yeah, of course. So how do you factor by using the difference of squares? So if you recall, it will still break down like this. Right? Something times something else equals 0. How do I make x squared? X times x, right? Now that's a negative 9, so I have to have a positive 3 and a negative 3. So x plus 3 times x plus 3. You see that? So I've factored using the difference of squares. Now I can go into the new stuff. So x plus 3 and x minus 3, those are my two factors, right? If I split it up right here, that's going to give me two equations. X plus 3 equals 0, and x minus 3 equals 0. Solve them like you would solve any other equation, right? Subtract 3, so you get x equals negative 3, or you can add 3 to get x equals positive 3. So this time it looks like my solution is x equals negative 3 or x equals positive 3. Both of the answers are the solution. They're two separate answers, right? I mean, really quick, let's just check that. Our original equation was x squared equals 9, right? Okay, so what if x equals 3? Wouldn't that mean 3 squared equals 9? And I'm pretty sure 3 times 3 is 9. So you get 9 equals 9. See that? Okay. Well, what if x equals negative 3? And go back and plug it in. Negative 3 squared equals 9. Now remember what squared does, right? If you square something, you're going to multiply it by itself. Negative 3 times negative 3, right? Negative 3 times negative 3. Multiplying two negatives makes it positive, so you'd still get 9 equals 9. Both of them work if you plug it in. So the solution is both of the positive and negative 3. So that's two more examples, right? I'd like to do one more example, and then that'll be it. I'm going to show you pretty much the hardest type of question that you'll see here. So if you're going to try to factor this, right? Well, clearly it's a trinomial, right? So we're factoring a trinomial. There's no GCF, right? 4 goes into 20, but 4 does not go into 25. So a 4, a 20, and a 25, they don't have a greatest common factor. They're not perfect squares. 4 and 25 are, but 20 isn't. It's not the difference of squares. I'm going to have to do my hardest method of factoring, which I guess sometimes it's called the British method, but it's the last thing that we had done before we left. So we're still going to break it down, but this time we have to follow a certain amount of steps. So if you recall, the first thing I have to do in order to factor something like this, and remember what's messing us up here is this 4, right? 4x squared. So the 4 in front of the x squared means I have to do something a little different, right? It's not like I'm trying to find numbers that multiply to 25 and add to 20. I have to do this, right? You should remember this. You take the 4 and the 25 and you multiply them, right? 4 times 25 is 100. Then you need to find numbers, right? You find two numbers that multiply to 100 and add to 20. So you need to find two numbers to multiply to 100 and add to 20. A lot like the example I started with, right? But this time, you had one step to do first. 4 times 25. And we've already gone over this. So I need to multiply to 100 and add to 20. So I need to think about all the different ways I can multiply two numbers to get 100, right? 4 times 25 equals 100, but 4 plus 25 equals 29. So that's not going to work, right? I could do 5 times 20, that equals 100, but 5 plus 20 equals 25. Also not going to work, right? I don't want to add to 25, I want to add to 20. I could do 50 times 2, that would be 100, but 50 plus 2 equals 52, not 20, right? Well, there's another way I can multiply to 100, and that would be 10 times 10. 10 times 10 equals 100. And guess what? 10 plus 10 equals 20. So it looks like the two numbers, right, that multiply to 10 and add to 20 is 10. 10 and 10, right? Now, this is factoring by grouping at this point, right? Remember, to factor a trinomial like this, you have to turn it into a factor by grouping problem. Yet again, something else that we've learned about before. How does factor by grouping work? You take the 20x and split it up as 10x plus 10x, right? How come I did 10x and 10x? Because 10 and 10 were the two numbers I got that, did what I wanted them to do, multiply to 100 and add to 20. So 10x plus 10x. The rest of it I just bring down, right? Plus 25 equals 0. Bring down your 4x squared, and that's a positive 10x, so I'll put plus. Now that I have 4 terms, I can do factoring by grouping, right? How does that work again? So you group the first 2 and the second 2, right? And after you group the first 2 and second 2, you have to find greatest common factors for each of the groups, right? 4x squared plus 10x. Well, 4 does not go into 10, but 2 goes into both numbers, right? And they both have an x. So my GCF is 2x. How do I fill in the parentheses? Don't you divide by the GCF, 2x? That's going to give me a result of 2x plus 5. GCF of the second, 10x plus 25. 10 does not go into 25, but 5 goes into both of them. So my GCF here is a positive 5. And I fill in the parentheses by dividing by 5 to give me 2x plus 5. And again, it equals 0. Remember, if you're doing factor by grouping the right way, you should get 2 matching parentheses. My final step with factor by grouping is to take my GCFs, right? I take the 2x and the positive 5, and I'll group them together. So 2x plus 5. And then the other parentheses, I group them as well. 2x plus 5. So all of that was review, right? This is something that you already should know how to do. The last step is to actually solve it, right? This is where I'm splitting it up and saying 2x plus 5 equals 0 or 2x plus 5 equals 0. Do you notice that those are the same equations? I don't need to solve the same equation twice. I'll do it in this instance just so you can see, right? I minus 5 and get 2x equals negative 5. Divide by 2, and I'll keep it a fraction, negative 5 over 2. If I solve the other equation, it would still be the same steps, right? 2x equals negative 5, divide by 2. You get the same number when you solve the equations because they're the same equation. So, at the end of the day, your solution, and remember I told you this would happen sometimes, is just x equals negative 5 over 2. The one and only solution is negative 5x. So, keep in mind, what are we doing? You first need to make sure that you set your equation equal to 0, right? Losing it. Right? Make it equal 0, factor the quadratic expression, set each one equal to 0. Most of the problems you get will be similar to this one, right? The example that I was just going over, this one. There'll be a few problems like this, but this right here is the most difficult problem, right? The highest level of difficulty is right here. So, I will be posting assignments along with this. It's not really that bad. We're going to stick with this concept of solving quadratic equations for a little bit. This is an incredibly important part of the year for us, right, in terms of the content that we're learning. Because this stuff, you are definitely going to be doing next year, right? If you're in elementary functions or pre-calc, 100% you're expected to know how to do this. So it's better to learn now, that way you're in a better position next year. Otherwise, this is pretty much all you need to know for this particular lesson. I also almost forgot, today, the number of the day is 17. Now what the heck does that mean, right? Every lesson that I post on here, there's going to be a number of the day, right? I will be asking you for the number of the day on Google Classroom, and that's going to be how you're getting participation points, because you're not going to know the number of the day unless you actually watch the video. So it's my way of you proving to me that you actually watched this lesson. So all you're going to have to do is tell me that the number of the day was 17. Pretty simple, pretty straightforward. It's free points. You're getting points just for watching this and then telling me what the number of the day is. Now, have a good day.